Well, thanks so much for joining today. I'm presenting today with Yilong on Python for clinical study reports and submission. Um, a little bit 4 years, same time 4 years ago, actually, we did a very similar workshop here at R Pharma on R for clinical study reports and submission. So there's only one very small change in the title, one word, right? I hope updating all the materials was as easy as updating the title. But apparently we put some efforts in organizing the materials today, and hopefully we can give you some take-home messages, and we'll talk about them a little bit later. Some personal anecdote first on why we wanted to actually do this. Um, so um, uh, Last year, when when we are looking at the state of things in our community and Python community, we realize that there might be some very useful advancements in Python that could make things work much better compared to 10 to 15 years ago. So I'm always kind of Python curious in the past few years. But every single time when I try to get something started, okay, I really need to code this up in Python and try things out. There's always something about setting up the environment and getting the packages installed and getting all the packages working together. And I'm always confused what's Conda, what's Anaconda, what's Conda Forge, what's pip, and how they work together, right? Um, but last year when I started to try all these new developer tools recently developed, for example, Rai and UV and Rough and everything involved, I feel that the time is here, and we should really seriously consider um, leveraging some of the tools in the ecosystem that to create something unique. And back then, also, I feel I talked to Yilong about this on the new emerging AI-assisted coding capabilities from other different vendors and model providers. And I feel like they can, since we already know um, exactly what we wanted, and we can critically evaluate the model outputs and forge things towards the direction we want. So we can actually leverage that to accelerate our development. So I talked to Yilong and said, maybe we should check this out and see if we can kind of replicate what we have done in the past few years in our community using R, and see if they can potentially help some real business needs in specific pharmaceutical kind of segments, including but not limited to the device space and also CMC stuff, right? So I think that's my personal motivation on why we started. But maybe Yilong, you also want to add something to the picture?
Sure, thanks, Nan, for the introduction. Yeah, similar to Lan, I start to use Python from this year, and probably if you know our previous work, we have been using R for developing some material for clinical study report submission. Now this is like a similar flavor to understand like if a team want to use Python for clinical development potential submission, how we can achieve that with existing tool and recent tool we have been developed. Yep.
All right, perfect. So we have four parts for this material today. So I'll probably give you some general introduction on how we think about setting up the Python environment today in 2025. I think there's there's one way of doing this correctly, that is using UV. If there's only one take-home message you can take from today's presentation, that's not our own tools, RTF Lite, Package Lite for Python, and everything else. That is that you should actually learn UV and use UV to manage your Python project environments. Then I'll hand this over to Yilong on using very useful packages like polars for data manipulation, and also RTF Lite for generating precisely formatted RTF tables in Python natively. And then Yilong will continue with some of our thinking around how to organize analysis and reporting projects as Python packages, while still being able to produce a very nicely looking Quartal website using that project. And eventually I'll wrap things up by going over this very straightforward commands for packing your Python analysis projects as components of eCTD submission packages. So yeah, I think that's our agenda today. And very important disclaimer: the views and opinions presented today are only our personal opinions. They do not represent our company's stance. So, with that said, we have a few training objectives today, and they are basically creating tables for clinical study reports, CSR, and organize clinical development projects effectively. How do you structure a project, and how do you use the existing developer tools to interact with that project effectively, right? And eventually, how do you prepare that analysis project as submittable packages in your eCTD package, right? I have to say that everybody uses or prefers maybe different tool chains, right? In different companies. So we might only want to provide a kind of a standard and common way to do things here, right? This is not the way of doing things, but it is a very standard and common way how we think about this if we want to start afresh in 2025. I've mentioned 4 years ago, we did a very similar workshop here. So if you are interested in how we do this in R, that has been reflected in our previous book, r4csr.org, and you can check that out. I think many things have happened in the past 4 years, like from the R consortium, R submissions working group. There has been 1, 2, 3, 4, 5 pilot submissions now, and people are having like different thoughts on how to do this effectively, right? So you should also check that out if you're interested. And I do want to give some big shout out to our R Pharma organizers. It is really a productive annual gathering event. And you should always please consider sharing your stories and use cases to expand and extend this community, right? And I feel like we have the original contributors as 4 years ago. The people haven't changed, although many things have changed, right? So that's important. And if you have any feedback to our presenting materials, please consider submitting a PR or issues to the repo and repos. So in this workshop, we kind of expect you to have kind of minimal understanding of how Python programming works, and you do understand what is eCTD and how people usually organize analysis projects as code assets, and how do they prepare them for submission. So just in case you don't have a local development environment, right? We have prepared a GitHub code space for you to reuse. So you can simply click the I hope Yilong can share the links of the slides and yeah, the book into the chat. So you can actually click this link to open the GitHub code space. And just remember to stop and delete that code space after you are done today, because that will count towards your free usage, which I think is 120 hours per month, which is pretty sufficient for today's purpose. But you don't want to waste that resource on unused hours. And we will use that GitHub code space to show you how do you do all these 1, 2, 3, 4 parts using UV, set up your project, having a structure, prepare the tables, eventually prepare the eCTD package, right? Apparently, the book is at pycsr.org. And during the workshop, we will be using all these different repos. So you'll be able to clone them if you use GitHub code spaces. But you can also do that if you use VS Code or Positron locally, if you can set up a local development environment. So I'll start with some very basic philosophy, very familiar stuff as we presented 4 years ago. So we do share the very similar automation philosophy as the R community, and that has already been described very well by Hadley Wickham's R packages book. That is to automate anything that can be automated and do as little as possible manually, but do as much as possible with functions and all these developer tools, right? And our goal is to actually focus and spend our time on the things that we really care about, instead of just thinking about all these very technical structure stuff. Although that structure might be important, right? But if we follow a very standard structure of doing things and the standard workflow of doing things, you will be able to focus your attention on the right things, right? In the long run, especially. So first of all, I want to give you a general overview about the Python environment setup stuff. This is very straightforward. So probably just kind of go over the slides and we can jump into the book chapters. And so you can actually try this out yourself. So obviously there are several options, GitHub code spaces, Positron, and VS Code, depending on which one you are comfortable with. Maybe you can just pick one, right? Although we will need to install the other dependencies such as UV or Quartal that is needed to render the book or the project. So you should be able to do that a little bit later yourself. UV, right? So if there's anything you need to remember today, that is you should consider using UV, or if you're already using some other tools, maybe consider migrating your projects to be managed by UV. So UV is actually a modern Python package and project manager written in Rust. So maybe a little bit over-engineered, but it is very fast, right? And it's kind of a combination. It's a very ambitious project. It's kind of a combination if you already know a lot of these development toolchain in Python previously. That's pip plus virtual environment plus PyEnv and pip tools and setup tools and everything related to packaging and releasing, right? Python package, the entire development workflow. And actually has some other components that we can go into later that will implement a lot of useful things like code formatter and linters and everything else, right? So I use UV every single day nowadays. it also follows a very modern Python standard, packaging standard driven by PyProject at Tomo, which simplifies all the scattered configurations around different configuration files previously in a very neat way. And it also supports this UE.log file, which records precisely which dependencies you have been using in this project, including their versions and sources, indexes, where they're coming from. So you can actually restore the environment you are using for this particular project very easily. Very, very similar concept to renv, right? And if you want to install UV, this is how you can install it. We have a link in the book chapter you can click. So that's the copy. This is all copied from the official installation commands. But maybe you need some special kind of admin privileges to install things. So just be mindful on that. And just to be clear, our GitHub code spaces has already have UV pre-installed, so you don't have to do that in the code spaces there. And I think we can probably just go to the book chapters if that makes more sense. I think at this point, and as you can see, we have some callouts here on stopping your code spaces if you're using that once you are done. And it might take 1 or 2 minutes to put things up and set things up there. So just be patient. I myself also has one installed, I think, or started. Let me check that. Okay, I already have this code space launched. So I can resume this code space and leave it there. Okay, so several options: GitHub code spaces, positron, and VS Code, right? And here are some kind of useful VS Code extensions you can install yourself for this particular workshop, but I find them useful in general during your Python package development experiences. And there are some VS Code settings you can set up yourself. Not super important here, but if you want to highlight the non-basic ASIC characters, this is the option you can use in your VS Code user settings. And obviously, we want you to be able to access a terminal because we will be using the command line interfaces a lot. We also encourage you to use AI coding assistants for this purpose and have some pointers in there. Now, getting back to UV, right? So for a very append, let me just make this larger if that's a little hard to see. Okay, I hope this is clear. So in Python, for very good reasons, you should always use per project based Python and package setup, right? Package library setup, right? Simply because there's very little centralized integration testing from the package registry side. So everything can just break the downstream compatibility with the downstream dependency, reverse dependency packages, unlike R. So you kind of have to be careful and actually lock your versions of your dependency packages, public packages, because they can actually break unintentionally. Plus your Python version, right? So that's a very important mindset shift if you are coming from the R world. UV, as we mentioned, it's a combination of different features of different tools that you are probably already familiar with, but are having maybe frustrations about. Hopefully not. UV follows the Python packaging standards, and you can install UV very easily. And here I will probably just do this using my local terminal or maybe the GitHub code spaces. Okay, so let's see, we can make this a little bit larger and not to build with agent mode. Okay, all right. So as you can see, by default, the GitHub code base actually clones the entire PyCSR project, right? And just to be clear, sometimes you might want to just close this folder. So it can return to the default state without the project open. Otherwise, UV might be confusing if you're just creating a UV project inside another UV project, right? But here, I think for this purpose, this is fine. So we can actually allow this pasting and do a UV self-update. So this is how you can update the UV. If I want to do this locally, you'll be able to see, okay, you are on the latest version of UV. If there's a new version, it will show that it has been updated from an older version to a new version. This is usually very useful when a new Python version is available. So UV is having all these very frequent updates. So to support all the new Python versions, you should probably consider updating your UV frequently or regularly. But this is not very useful for our particular purpose today. And then we can just initialize a project using UV, right? Let me just copy this example here, and I'll just go to File and Close folder here to close this PyCSR project first. Later on, when Yilong is presented, you probably want to open that folder again, right? So that's very important to have the right context to run things. So here I'm at home, right? So nothing is here. PyCSR is here, so that's important. But I'll just initialize a new project called PyCSR-example. Not very confusing, right? So allow, and you can see you reset initialize the project PyCSR example at this location, right? Then we can maybe go to the example here. You can see there are several files being created, including the git ignore. There's an example main.py. There's a pyproject.toml, which is the package metadata that drives every single Python package or analysis project we'll be learning today. And then there's a very interesting file called Python version, which records the exact Python version or the specification you'll be using in this project. And there's a readme.md, right? Simple enough. I'm not unfamiliar as the all the other languages, how they organize their projects. But here we'll just see this very basic structure being set up, as you can see in the demo, right? Although we might want to get this analysis project into the right shape if you want to build it as a standard package, especially with a build system setup. So Yilong will talk about some of that in his part on organizing analysis projects. As you can see, this let's explore a little bit, right? If we want to check out this pyproject.toml, right? We can use less, right? And this is just very, very basic setup from the template from UV. So you probably want to extend these things to to a better state later. But there are some very important sections I think mentioned, especially on the project section, which includes some package metadata. And then you'll be able to have some project dependencies set up. And also, so these are the hard runtime dependencies required by the package, similar to the R package import section in the description file, right? And these are and the dependency groups, the dev records the development dependencies similar to the suggest sections in the R package descriptions file. Build system, this is very important for declaring the build system in Python because there are several available options in Python, right? So you really need to just choose one that's compatible with UV to be able to package packages into tarballs and be able to publish them later. And then you'll be able to see that there's another very interesting file called the Python version, right? This file records the exact Python version you want for your project. Although here, as we can see, the example only used a very x.y version. And in reality, you might, depending on your project, you might want to specify the version a little bit more precisely. For example, 3.3 xy x.y.z, right? So the exact Python version can be used because if you only say 3.3, 3.13, then anything from 3.13.1 to 0.9 will be used whenever a newer Python version is released, right? So that could potentially break things for you, although unlikely, right? Unless you use some very, very, very deep Python related features, right? So that's a kind of interesting point. And you can actually use, pin a very specific version using Python, UV Python pin with the version you need. So if we do that, it will say updated this file from this version to this version. And if we check that file out, it has already been updated here, right? So that's how you update the metadata for recording the Python version and package metadata using UV. And you can actually list all the available Python versions using UV Python list. And here are all the kind of mainstream versions you can actually pin and restore using UV. And then you can actually install the dependencies we mentioned, the hard dependencies and soft dependencies. So here we'll just demonstrate using adding several dependencies. For example, polars, RTF light, and you'll be able to see there's a log saying, okay, all these dependencies don't have conflicts, they're resolved and can be installed, right? And if we check, this will actually update the PyProject, the .toml file, right? And install the dependencies. So you can see this file has been updated with all the versions, specific version requirements for these packages added to the PyProject toml file sections. And then you can also add similarly development dependencies that's only useful for development. For example, you want to add the rough dependency as a code formatter and linter, and maybe also you want to create some unit tests for packages using PyTest, right? And you want to have some static type checks for packages. So you can all add these things using UV add --dev with the package names, right? If we run this, it will output very similarly and update the PyProject toml file, right? The dependency groups.dev section with all these optional dependencies or development dependencies installed and declared. Later on, we can also remove some of the dependencies that are not needed. So you can actually run UV remove dependency name to remove the dependency from PyProject.toml. But everything converges to one point, and this is the most common UV command I ever use, that is UV sync. So whenever you have updated the Python version, added a new dependency, removed the dependency, updated the dependency version requirements, you might want to run UV sync, right? To actually update the log file in the project. As you can see here, this is a little bit buggy. The UV, let's check out the UV.log file. This log file actually records, as I mentioned, all the dependency versions and sources, right? Exactly what they are. So we can restore them very precisely in the future. And UV sync actually sometimes does all these actual actions for updating the your dependencies in the virtual environment it has set up, right? So that is very important to know. So run your UV sync regularly. Always do that when you start when you actually open a new project you have already you have just cloned, right? So to make sure that you have the exact environment that developers expect you to have, right? And then you can also have all these very useful commands for updating the dependencies, the log file and everything else, and sync again, right? Using UV log upgrade. But most importantly, I wanted you to know that you should always try to activate the virtual environment so that this command can actually put all the tools you have just installed, right, in under your shell, so you can use them directly. For example, if I say PyTest, right? Okay, this already has PyTest installed. Maybe rough already has not having that installed, right? So if I run rough, this tool is not available under the current shell. But if you do activate the current environment, right, that can actually make this available under a current shell. So you can actually run all these commands, right? Using the available development dependencies you have declared in your environment. Then you can also run very specific commands, right? For example, if you do UV run Python, that will run the Python that has been installed in the virtual environment for this project. You can also run all these commands if you don't have already activated the environment, right? Just in case, because sometimes it's not very easy or recommended to source the activation file to activate the virtual environment. So you might want to use these instead of doing that. There's also a very useful command called UVX, which is magical. It actually can run any dependencies that even hasn't been, or command line interface tools that hasn't been even installed in your Python virtual environment. So I will be running some of these UVX commands for demonstrating the PackShite package for packing projects into submittable packages in the eCTD package a little bit later. And then you can actually declare your build system you prefer. I personally use hatchling, which is doesn't really give you too much to configure, but it works pretty well for my use case. However, depending on your use case, you might want to look into the build system options in the UE documentation, because there are a lot of things to configure. For example, if you have a C or Rust interop in your Python package, you might want to configure your build system so you'll be able to build the right views, i.e. the binary tarballs in R, right? For users to install directly without having to install all those development and build toolchains themselves on their own machines to install your package. So all these things will be very important. Here you can actually run UV build to build all the tarballs if you want to distribute and publish them later on in the on PyPI, right? Or PyP. Sorry. So you'll be able to search and find all these packages on PyPI, very similar to CRAN. And you can see their release history and everything. So you'll be able to check out certain version requirements for packages. So you don't require something that's too new that will break other things up, right? So that's that. And eventually you can run UV publish to publish your package to PyP. So in the interest of time, I think I'll just have a very, very brief summary of the modern Python toolchain. So in R, you have packages like DevTools, use this, style R, linter, and test that, right? For solving every single critical step during your development process, R package development process. And in Python, we also have awesome developer tools built for everything and maybe more, right? And here we just recommend a few very common tools today that you can leverage and use for implementing all these very useful steps in Python for Python packages. So I would say obviously use UV for package environment management, use rough for code formatting and linting, use MyPy for static type checking if you do have type annotations for your Python packages, and PyTest for unit testing, obviously. So I would say PyTest is basically a kind of the test that for Python. It has, I think, more than 100 plugins for implementing all these very useful unit testing features that has not already been implemented in the core package itself. So definitely try out PyTest if you're interested. And then maybe Quarto and Quarto Doc for creating documentation websites and reporting purposes, right? Although I would say there are also some other very decent solutions, such as MKDocs material, which has been used by all these packages we see, not only in Python but also other languages. So definitely check out all the options out there, and all the tools can be installed as development dependencies. As we mentioned, they are mostly a Python package, right? So they can be added using UV add --dev something, right, into your PyProject, Tomo, and organized centrally there. And for rough, you can actually add rough as a dependency and run something like UV run rough format to check things out. This will give you something, okay, one file left unchanged. Otherwise, it will say, okay, we have changed a few files because they are not conforming to the standard formatting it promotes, right? So that's a very easy and fast code formatter for everything you can discover all your Python files, or you can use it on the fly using UVX, right? As we mentioned. You can also configure what format you prefer in PyProject or Tomo, but you can check out the documentation yourself on how to do that. For code linting, you can run UV run rough check very similarly. This will give you some recommendations on what can be fixed automatically and what cannot be fixed automatically. So you can check them out. It will give you very precise references to all the standards it can support. And you can also configure what linting rules you prefer in your Python project or Tomo. And we have some very nice examples. UV also has this official kind of documentation recommendation on a very popular set of configurations you can use for your package, right? For example, in our package, package for Python, right? We have this we have these things enabled by default using very popular linting sets from the community, including but not limited to Flake8, isort, PyFlakes, and everything else, right? So you can actually see what you prefer and actually enable them in your configuration files. And then, yeah, as we mentioned here. And then maybe you have heard about type annotations, type hints, and all these keywords about typing in Python. I think it is a very important feature for large team collaborations, because in reality, one of the biggest common problems I see when bigger teams are collaborating with software and API, I think more than 80% of the problems I see are actually coming from the fact that your inputs and outputs are not correctly formatted or specified. right? And typing in Python actually solves a lot of these headaches in a very standard way, right? If every single team writes their software with strong type annotations and enforce them using tools like Pydantic, right? Then people will dramatically reduce these kind of issues if they know how to do things properly, right? So you might want to have some, but since this is a very big topic, you might want to look into it a little bit later. Just know that there are a lot of tools available for type checking, and here we are just using the most common one called MyPy. You can use this as you use all the other developer tools using UV run or UVX run to do static type checking for a package. And although I know some people use Pyrite and everything else, but all those things belongs to another day of topics. So here are some type annotation example on how you can read these things, but that's probably later read more topic. Yeah, so these are all the very useful pointers for type checking, but I'll just skip that. And here is how you can test things with PyTest. I think Yilong will give you an actual example using his analysis project example a little bit later. But just know you can just run PyTest very easily, as we probably have or not have demonstrated, right? I can run PyTest. This will actually run through all the tests available and give you a very standard output that you can parse and make AI tools fix all those test issues for you, even if you don't want to fix them. But do verify and have human in the loop and check if that output from AI or fix from AI is actually making sense, right? And then here are some pointers on how you organize the tests. Not surprisingly, they belong to the tests directory, so just like in our packages, right? And how you can organize them properly. You can also write parameterized tests to save the length of code and everything else, right? And then you can generate code coverage. We generate code coverage and put that into our website I think in RTF Lite here. And you can actually check this out. It says generated by the PyTest coverage module. So you can see exactly in which files which lines are covered and which lines have misses. You can see a lot of things are covered, but we have a few exceptions not covered here, right? So this is very useful for checking out if your code has been covered by your unit tests, and this has been very useful. And overall, we have 86% for RTF Lite, relatively decent. It can be 100%, but you can always improve that later. But that's probably a task for Yilong. You can see a lot of options for generating documentation websites, and we have them generated using Markdown MKDocs material for our packages RTF Lite and Package Lite for Python. Although you can have all these alternatives using, for example, QuartalDocs and everything else, right? But it will just a very simple exploration topic for yourself to see later. So I think that's everything I want to cover from formatting code to checking your code to creating unit tests in your package and then generating reports or documentation websites using Quartal or other useful packages, dependencies. And then you can have a relatively standard project for your package. Although I would say it's probably, since many people ask this, I have to clarify. It's probably a very, very bad idea to mix a R project, R package with a Python package in the same directory. So if you ever needed that, you should probably consider separating them into different directories, although they can share inputs and output directories. So you can actually do them so that you can actually separate the concerns, right? And how you operate on different packages. So yeah, I think that's a lot of the things I want to cover. And we do have some example repositories you can check out for the analysis package we created using Python as a standard Python package with batteries included. And this eCTD package example where we pack this example package into the module 5, right, in your ZC package that you can use a little bit later today with Yilong. So yeah, I think that's everything I want to cover. So do we have a break or something, or I should
Yes,
handle
let's
to
have a
Yilong
5 minutes
directly?
break. And
Yeah.
if people have any questions, please post in the group chat. So I think Nan can take some questions while we are taking break. Yeah, and I think Yaling had a question about if there's a way to do UV code setup for the positron and also how to maintain the dependencies.
Oh yeah. So positron is mostly IDE, has all the batteries included, but I don't think it has UV included by default. So if you want to install UV, you should go to the UV website and see how to install that, right? And everything is separated. They're not very coupled together, right? So you can install positron, install UV separately, and run UV commands to manage your Python project, right? So you can use different things for each thing, right? So that's the flexibility and beauty of the Python community, where you have many options. Although it would be good to know which sensible default you want to use and prefer in every single step, right? So in this book and materials, we just want to give you some pointers on which things might work out of the box and without too much configurations. Right. I hope that answers the question.
Yeah, thanks, Nan.
Yeah.
Maybe let me share my screen and we will
Yeah.
start in 2 minutes at 10:55. Okay, cool. I think we're right on time. Let's start it. Thanks, Nan, for taking the heavy lift about the environment setup, because that's always a hard question when people want to use Python, especially like when we think about clinical trial environment, right? We are always talking about deliver hundreds of tables and figures in a clinical project. So to ensure reproducibility and to ensure everyone is configured in a collaborative environment is critical. And for here, actually, I will go with a simple one and actually probably more familiar with people who are in the pharmaceutical industry, starting from how to create a table listing and figures, following the ICH E3 guidance, like to get some simple table, and also how to assemble them into an analysis package. Right. So to get started, I think the first step is to think about what's over data sets. And typically in a pharmaceutical industry, we always use ADAM data for those analysis-ready data set to generate over table listing and figures. So for here, for simplicity, we also assume that we already have some ADAM data available. And thanks for the community, there's a CDISC pilot data believe have been used in many, many times in different locations. So we will start to use this data as well. And some difference is that we already convert the table into a format called a Parquet. And this is a similar idea like the R data in the R environment. You have a very condensed way binary format to store not only the data and its format. So when you load the data, you load it as is and ready to go for your analysis. But when we do the submission, we still think about XPT as format or data JSON as an option for the recent movement in the CDISC kind of community, right? So another part is that how to get data ready for analysis. You need some tools within Python. People might familiar with pandas and other tools for visualization. And for our workshop, actually, we adopt using polars. That's also a data manipulation package in Python with very similar grammar style, like dplyr, tidyr, probably people already familiar with if you are coming from the R community like ourselves. And also, like in the pharma, we also need to sometimes generate the RTF tables to be the production ready results to be shared with our clinician, medical writer, or other members, right? So that's inspired similar design from our package R2RTF we developed together. So RTF Lite shares a similar syntax, but more in a way designed using Python. So before we jump into a table directly, let's get some simple flavor for Polar first. On Tuesday, I think Mike already have a comprehensive discussion about the Polars, the standalone workshop. For here, let's just give a very brief idea like how Polar looks like. And also nowadays, thanks for the AI. If you already have some tidyverse code, you can always ask AI to translate your polars and see how the syntax looks like, right? And online, there's always some cheat sheet to see, hey, how the comparison looks like. And we also have a dedicated chapter about Polar to go deeper, a bit deeper for some commonly used data manipulation in clinical trial. But generally, you can think of Polar is more like a fast version of the tidyverse in R that basically uses Rust and enable parallel execution. And even when we talk about those high performance computing, GPU enabled, so Polar already have the same syntax for everything. And also memory efficient, that means a lazy evaluation is enabled. That basically means if you really need to handle large volume of computation, you don't have to calculate on the fly. You can just define the schema and grammar and do the computation later and let the Polar to tell how to do it efficiently, right? And another thing about strong typing, that's one of my favorite features in Polars. You need to ensure that you don't get any surprise when your code be there for a while, right? Those strong typing ensure certain capability to prevent such error. So whenever you see an error, you want to see it early instead of to wait until you see the final results, and that becomes hard to debug. Right? And another thing I think is always about the syntax. That's easier to learn, and I think it's more natural from people migrate from tidyverse. And this is some simple example of Polar syntax. You can see that you can use the same idea like filter, group by, or pivot to do the data manipulation in different perspective. And also you have different way to import CSV or other type of data set into Polar. And also when we do like a very basic data manipulation or analysis, you probably want to do some aggregation and you want to calculate percentage. So these are just some very simple syntax that can be used in over later on analysis examples. And then let's go think about the RTF Lite. So if you have been using either SAS, R, or Python to deliver results, so the last step for clinical trial reporting is to deliver some production-ready table. And someone using RTF, someone using the Microsoft, and or sometimes just a plain text. But anyhow, you need to develop into a well-formatted table for the medical writing and to make sure that's reproducible. And RTF Lite is only focused on the formatting part and to make sure the table layout, font size, board type, those type of things are already handled and visualization is always in mind, right? So in this case, this design and package overview and also RTF Lite is also able to handle the figure. Like if you have an existing figure in different format like PNG, JPEG, you can just read in and insert into the RTF table. For the table itself, it also have a refined control of table column, footnote, title, or data source. And if you need, it can be spanned into multiple pages as needed, right? So that's a general idea here. But how that mapping into a code, right? So here's one quick example of the code. So essentially just import a polar as an input to get the data ready. And you have RTF light imported. And once we just read in one data set, let's just say ADSL or ADAE. And this is a very quick example to say, hey, now I just get RTF document as starting point, define what the data, that first 6 data point, and you have the RTF body to define the body layout in the default setting. Now you can just generate an RTF file. Here is just a flavor of the output. I just transfer into PDF for easier presentation. But on the end, it's actually an RTF file that can be opened from Microsoft Word. Right. So here is a summary of the RTF Lite capability that visualized to like a production ready listing, right? So because even listing the concept is simple, but actually that takes most of the features required by RTF Lite. So you can have the page header, like a page number, right? You can have the title, subtitle as needed. And sometimes you need a subject line outside of table. And you also need column header in different format and page by group by features in the listing as well. If needed, footnote inside of table, RTF, the data source outside is also possible. Or if you want, you can arrange in different way as needed. In the end, if needed, the page footer is also being designed into this design for both RTF Lite and similar to what R2RTF have been provided. So this is a general concept. I probably go a bit quicker here. You don't have to remember everything here because you have AI, right? So whenever you want to do anything, just ask how this can be handled in AI, or more conveniently, if you are working with a VS Code environment, you can just take the snapshot of a table that's desired, like then put into the AI agent to let AI give you some initial answer. Okay. So to make this a bit concrete, let's also go to a GitHub code base environment like Nine just shared. So in this case, if you want to just quickly learn some polar example, it's available in the TLF overview chapter, right? So that's a Quartal document. If you're already familiar with Quartal or Markdown, it's very similar syntax. The only difference is that now you are running the Python code instead of R code. And with Jupyter and the Quartal extension, you can just run the code on the fly. See, we can just run above, and you already import polar, right? And also for here, you can just import the ADSL data set. And now you can say, hey, I have the ADSL data as a starting point, and I can just get some data sets quickly like this interactively here to further explore what you are of interested. And also it enables IO like we said. So in this example, we use a read parquet that's already have data stored into the data folder, and you can explore for different type of thing as needed. Right. So and do the filter like we said, and you can just filter the female. And similar idea, let's just jump to the RTF Lite. So you can get RTF, and then this part we will skip, but let's give one quick example. So we read a parquet file, and we do the data set manipulation. This is a bit complicated polar syntax, but ideally you can see similar flavor like tidyverse. We group by treatment group and AE code. We calculate the count and we sort. And this sort is actually always important in polars, because to enable parallel computing, they don't maintain a sort by default. So if you want to ensure reproducibility, always sort as desired. And then you can just pivot to the table, so you can get a table that's almost ready for the analysis with the next example when we do the AE listing or AE specific, right? So that's how like a manipulation can happen with a table. So the next part is that, hey, now I have a RTF like document like we just show. We have the first 6 one and get RTF table. Now we can just run and get output into the RTF folder, right? So that's how in the project, you can see all the RTF file has been pre-calculated, but we cannot preview directly in this environment. If you are interested, you can either just download the file to your local, so you can open from Microsoft Word, or you can just look into our GitHub code base. There's already a PDF version over there, or more conveniently, just look the book that's already have the examples render for you like this. Right? So that's all different way you can try. And more importantly, you can try with AI. Right? There's an agent, and you can say, hey, how I can use coders to convert a long table to a wide. Let's say just very simple thing. And probably you need to register an agent. And my impression is that GitHub Codespace gave you some free allowance to try with different type of the simple model. But if you want to see advanced model, you need to get a subscription, right? So similar idea for Positron and for VS Code. There Codex, Cloud Code. So I think now always we discuss try multiple version, don't just stick on one. Otherwise, like this keep evolving month by month, competing with different AI company, right? You always want to say, hey, how they looks like with each other. But nowadays, it's really become simple and lower the bar for people to learn a new language. So you can see they gave a lot of the detail for you to start with, and similar idea. The UV part, the real important thing is that you have a mindset. Hey, I need to use UV to manage my analysis project. The rest of thing, when you start, just an iterative step with AI to say, hey, how I want to learn ABC and to make it happen. Right. So that's a general concept and personal experience when I start to learn Python. I think that works very well. After 3 months, it feels like smooth to use Python for some simple data manipulation and the work to be done. Right. So this is some general idea for the polars and for RTF light. And let me see. Yeah. So now let's go to a concrete CSI example, starting from the disposition table. And we have a multiple chapter for different tables, like the similar flavor for R2 RTF and the Alpha CSR book. So similar idea. The AI is really powerful for help us to do the translation. So what you see here is many times we collaborate with AI how to translate the content from our version to the Python version. It goes very well once you have the AI to learn the RTF light context and give more resource as needed, right? So as here, as a quick demonstration, this is the same disposition table we can create in R. Now we can think how we can create it in Python, right? So it's a very typical one. Every clinical study reports needed as like one of the first table. People want to see how the enrollment looks like, what subjects being excluded for the analysis, right? So in that case, let's just import polar and RTF light. And the first step is always load your data. And for this one, ADSL, the subject level data is more than sufficient for us to create a table. And if you're already familiar with the data structure, I think this variable are quite common for the Adam data schema. And for here, like we have subject ID, we have treatment group, and treatment group N is always good to define the order of the table, right? So when you sort always in a desired fashion. And then this discontinued flag and discontinued reason. In that case, all those 5 variables can be used to create the table we just presented. So first step, let's examine the data set. So we just use the select to get the 5 variables, and you can see the first 5 columns like to get the information we're very familiar with the ADSL data set. And then this is a quick example to get a count table. Again, just use AI if you're not very familiar with the syntax or the information. But the concept here is that you group by and you aggregate by the number of subject, right? And with columns, just doing the mutate of the column a bit while. So you can add some constant, right? So participants in population, what we want, and polar always give you the column type as a reminder. So we always remember, hey, this is a float, that is a string, right? And then convert it into a wide format. So we're using 0, 54, and 81. So that's how the sort is enabled for the treatment group. And this can be formatted as needed when we do go to the final production table. That's how you can see the TRT01PN is used here instead of the direct string. Also, similar idea, we can repeat the same procedure to do the count table. Because this is the first table, you can see a lot of duplicate code. And in the next one, let's test a bit more how to develop functions and get it more like easier to maintain, right? So assuming we get all the count table, and let's just jump into the combine all. So the end of the data manipulation is to get like a formatting ready data set. So this data accept the format. So all the content of the number and column already be there to format the table, right? And here, this is just a code chunk, how to format the data we just see into a format. So you can see, we just select the desired column in order and get the title, get a column header, and the column header is defined in the relative ways. Like we want the first column to be a bit wider using 3, compared with like the rest of the column is 2 times 3. Basically, we have the rest of 3 column as a title. So you can see here. So this is the output, right? So we have about 3:2 ratio for the first row of that column header for this blank row of blank column and placebo. And similar idea, you can have the second column header that have more columns, and with the first column still be 3, so it's being matched together. And the rest you split into the n and percentage, so to get a 1-to-1 ratio. That's how you can get a split and nested column header for some complicated design, right? And in the end, you can have an RTF body to design the column way similarly and adjust the text like this, the left adjusted and this is centered, right? So similar idea, however you want to present the table. So all those functionality is already being enabled. And also sometimes we need to control a border, like we have the left border here to be single, and we want the middle here to be blank to make sure these two combine as a one single block for the presentation. And in the end, once you feel comfortable with multiple iterations for the format, so you will write the RTF file into a single file. And if you are interested to convert RTF to PDF, the current recommendation is to use LibreOffice. And in that way, you can convert RTF to PDF and present like this way. So when we go back to our project, so we have multiple examples here, so it all can be executed as needed in the code space. So let's just go to a code example for the disposition table. So let me close the AI chat a bit. But the good part of this is you can always just jump into the desired chunk. Let's say, let's just go here and run code or above. So now we get this table being directly executed on live. And then we can just try this part of code. TBL, oh, sorry, I just run above, I forgot to run this alone. So you can get this data set and run the seal. So you can see this disposition table has been generated into the RTF folder. So just in case people want to say, hey, is that real? Let's just remove the RTF folder, right? So you can see RTF file should be expected to be generated here. Did we see that? Oh, it's here, right? So that's about the RTF file. So now you can just download. I forgot if I have Microsoft Word on this computer, but let's try that. Yep, it's lucky I still have that. All right, so now you can see output directly on your machine, right? So that's about the concept. Hey, now we have a data and we have a way to generate one single table. And similar idea, if we are interested to generate a baseline characteristic table, right? So this part, let's just walk through a bit deeper to see how we can use the function to reduce duplicated code in Python. So similar idea, like you can just import the two package, Polar and RTF. And then this is just config to show the first 5 rows by default for the polars. And the first step is always, hey, now we get the ADSL dataset to select this first 5 variable. And then this is a definition for sample function in Python, right? So in polars, we get this basically group by treatment group, and you can use the aggregate function to calculate for different column. And the interesting thing here, you can just define the variable as needed. And it's also okay to define multiple variable in folder. Like if this variable is a list, you can actually do that at the same time. And in these functions, if you're familiar with the syntax, basically just get the summary statistics, nothing fancy, right? And with this part, we can just define this function and summarize the age. And similar, so for all other continuous variable, you can do the same thing. And similar idea, we create a helper function for the categorical variable. So in that case, we can just count the sex for here to get another table. And similarly, we can get a race. And just a reminder, for production, you don't have to do it by yourself. There's already some table one package available for Python. So you can just rely on that. For here, it's just to demonstrate step by step. Hey, if I want to do this Python from scratch, how should I do that? And with this three, right? So now you can just do some formatting as needed. And in Python, always think about this F string or those type of the formatting strategy. So for here, so if you're new to this, my recommendation is, as always, you just copy this into your AI. So help me understand. So in that case, I think Python is your AI is a good body to learn, hey, what's the exact meaning of each of those single code? Because nowadays, I think they already have a very good understanding for some Python code and give you some guidance how to make the Python code written more efficiently, right? So always ask some advice of refactor will be a good way to think about. And same idea. So after we format the age, so we can format the sex and the race as needed. And in the end, so let's just skip this part a bit. It's basically to do some additional formatting. But in the end, this is the output, very similar to the output we're likely to build into the output for RTF file, right? And also the last step, like we discussed, wait, it's here. One moment. Okay. So you can see the format very similar to the disposition table we just discussed. So we can have the title, and we can have a dynamic column header, and then we can define the text justification for the RTF body and for the relative width and with the data source, right? And then the data output can be stored into a output folder. So let's just try this code. now it's being output into the TLF for the baseline. So let's just open that. Okay. Okay, it's here. All right. So this is basically the output we can get together. One interesting thing, if you are very picky, you can see the title case used in Python bit slightly different compared with R. So if you want to treat it carefully, you can do some additional data manipulation before you go into the data format, into the RTF formatting stage, right? All right, I think we covered single table well. I hope this gave you some general idea about how to create a single table. And if you are interested, we have additional example commonly used like to define the analysis population, efficacy table, and the adverse event. But due to time being, I will just skip those content for you, the reader, to explore either in the book or in the code space. All right, then I will give you some idea about now. Let's say we have a group of output. So let's go back to say, hey, this is a group of the output we have been generated, and what's the efficient way or a more organized way to assemble them together as an analysis package, right? So analysis package, like for clinical trial, we definitely expect there's some internal package that's being developed by an organization. And we also expect a few quartal file that store the analysis code like we just shared together. And in the end, once you have this analysis package, how to summarize and package it together into a eCTD package. That's what Nan will share in the last section, right? So in the end, so we are more thinking about the software development lifecycle from planning, development, validation, and at the end, the running batch at the operation stage. So that's some general recommendation we want to discuss and share, and it's also open to the discussion if you have some good thoughts on this. So first, the project, like now briefly touch in the first part. So what we are thinking is a folder structure starting with the Python package, but add some additional necessary folders to organize the information, right? So we are thinking about to have a data folder and output folder, and also the test folder that's always needed. So you can store your source data, output, and some validation code in those parts. And if you have additional functions, like the baseline characteristic example, we have some functions to reproduce that can be stored into a standalone package. And then the analysis code can be stored into the analysis folder as a quartal file. And we also have some config file as a package to maintain the dependency, maintain the Python versions using UV. And the uv.log is a log file to say, hey, if we want to port this code from one place to another, we can reproduce the running environment using UV. And you can also open another GitHub code space. So that's for our demo project. And we'll also take a few minutes to set up this project. While waiting, let's just take a look. This folder structure mimic what we just discussed. So the general idea, like we discussed, we have the data folder to contain all the ADAM data sets. And we have the output to store all the defined output as needed, right? And then we have the test, but I guess kind of blank. Oh, you have just very simple one for now. So you can do some unit testing or integrate testing as needed here. And in the end, so in the demo 01, so we have been stored the functions we just discussed in the folder. and also add documentations. That's always good if you are sharing and collaborating with a team member, both internally and externally, right? So that's a part about of the functions we just see. So in this way, when we jump to the analysis part, so you can have the baseline code to be much shorter and reuse the functions that has been defined into the internal package. Right? So with all this, so given this are all the quarter file, and can have a quarter object YAML file to config the layout of this project. So running batch become very simple. You just can just use a quarter render to render the whole project as a book project. This is how this book has been rendered as a demo to be run everything in batch. So you can see all the output as a log and see the final results. Oh, the results haven't been covered, but you can see the output is already been stored into the RTF for each of them. That's just mimic the PyCSR book as a demo project. Right? So that's okay. We're good. Now we have this project enabled. And what I just want to quickly show you is, let's see if we have Portal already. It can take a while. Or I guess I haven't enabled the UV environment. You need to do some UV sync. I probably will skip this part, but basically the idea that once the quarter is already here, the quarter command line is available, so you can do the quarter render to run the project as a whole, right? And you can also jump into the analysis code if you are still in the development stage, like we just demonstrated before. So to develop and update the code interactively and using the version control environment to keep the change and collaborate with people following the engineer best practice. Right? Let me go back. Okay, so that's about the high level, what we're thinking as a package. It's also mimic like when we talk about the R for CSR, we are thinking about using R package to store self-contained analysis project. For here, it's more like it's a Python package and also contain analysis folder for those quarter file as a quarter project to be like a running batch together. And the benefit is that if you think about multiple clinical development project, that's all for the same project folder, it will be reduce a lot of communication costs and the learning and become like easier to learn for people already on board. Right? And those consistency will help the organization together to lower the bar to maintain the efforts. And also for the reproducibility, the UV become important to maintain the environment. And if you need to do the validation of your environment, right, that's also a critical step. For here, we haven't touched that part. Like there's a lot of efforts on R&D to do the R validation. On the Python part, you always need to think how I can get my regulatory controlled environment to maintain and develop clinical trial if you need to fully comply. But that's out of scope for the current conversation. Right? And in addition, so you can do a lot more automation with the existing tool for those SDLC steps, including documentation, running batch, test, all those being able to build on top of the existing tool. And also last but not least, the compliance. That's always important for the clinical trial development, right? To make sure standardized within org, even beyond org, makes things much simpler. And I think that's a beauty also for the open source project. Let's start with this as an example and see how we can get it learned from different organizations who are interested to use Python for the end-to-end clinical development. And always like a Git is not the central way for team to collaborate, right? So now we have been showing like always use the plain text workflow, and over recommendation is always avoid those Microsoft Excel as a tracker or as a documentation, because that become harder for version control or for like as a computer or even AI powered way to do things in a streamline, right? And also those project tracker. So we have some example. You can either do it in a plain text or you can use some existing tool like Kanban or different project management tool that's already available and potentially integrate into your project management if you have multiple trial you have to manage as a team lead. And in the end, so beyond just deliver one single project and single table, the larger picture for organization is always your process, your development life cycle, right? So build up the process, SOP, execution resource to help people to be able to follow step by step, especially with some helper tool will also be important. I think all those were starting from the right folder structure that the organization can be fully aligned and those automation tools people can leverage. So all this is like link back to the first part when I discussed about UV or other ecosystem around Python. So based on our experience, I think that should be sufficient for clinical development. However, it's definitely not a trivial effort to learn all those tools and make it more efficient into a specific organization enterprise environment. So definitely work with some expertise, or if there's some data engineer or like an infra member in your team, always be allied with them and talk with them through what's the recommendations to build up the end-to-end environment in an organization before like starting to say, hey, I need to transfer all my project into Python. I think that's definitely the first step, right? For here, it's more like to give you some flavor as a statistician or as a clinical developer, what can be the essential item all assembled together to build a clinical start project and potentially a submission. So I will stop here and probably we can take another 5 minute break and with questions. And the last part is the most exciting part, as Nan will share with us about how to assemble them as a submission package.
There's a question in the chat. Really interested in the part about AI and learning. As a student, I wonder which parts AI can genuinely help with and which parts should we not rely on too much.
Sure. That's a very general question. It's also very important. So I saw AI like a partner, and it helps me learn fast and debugging things fast. But you always think yourself as a driver for project, right? AI will not tell you, hey, is this result fully 100% right? You always hear the term like hallucination. You will be responsible to be a reviewer for your result to make sure it's accurate and production ready, and also fulfill the needs for your stakeholders. Nan, do you have any thoughts?
Oh,
Just
yes, absolutely. We do have a kind of section in the environment setup chapter. I will just paste that into link and to everyone. I have a personal opinion about this. This might not be true for everybody, but from my personal experience, I think AI is obviously a very good co-pilot, right? But just like Yilong said, you should still be the pilot, and you should not be the co-pilot, right? So that comes down to how do we effectively use AI tools in our entire development workflow, right? So I think to be successful at any degree, or ultimately, we need to have two mindsets. First of all, you need to be the product manager of your project, meaning you need to know exactly what you want to build. That comes down to all the dependencies, which one do you prefer, right? So you need to definitely do some research and prepare your prompts properly. I often take more than 20 minutes to construct a useful prompt if I want to lay out some details on how to create some projects from scratch. And second of all, I think you need to have a software architecture mindset, which means you need to be able to evaluate the model outputs critically, right? For example, does this change actually make sense, right? Or is this just kind of solving the need or question on the surface level, but actually makes things worse for the bigger picture, right? So to do that, you need to actually know some details about the language you are programming in, right? And not really let AI be the pilot and you be the co-pilot in the entire process, right? So yeah, a few thoughts in there. And we have another question. Have you guys evaluated the gaps between R and Python for available statistical models and packages? Just want to understand when it's a good time to use Python for analysis.
Yeah, good point. Depends on because there are many analyses, and definitely I think I is going to have like a many choice for different type of analysis. So far, for my clinical project, I think Python is more than sufficient to cover. But one well-known like gap for pharmaceutical is the MMRM, right? I haven't aware Python have an existing package to achieve the same level the MMRM R package is being available. So if Daniel's here, we probably should ask Daniel to comment.
Yeah, I agree. There seems to be some basic statistical models available implemented in Python packages, but there hasn't been, I think, major implementation for a lot of the, the linear mixed models available in there. Although I would say if you are doing a lot of machine learning and deep learning specifically, then Python is probably your go-to language today, right? So, um, yeah. There's another question saying, have you joined today's meeting? I'd like to know if there any pharma have submitted a package using Python.
Yeah, that's a question remind me like back into 2018, right? So we are at the day zero. Let's say we just share the experience and potential, but so far haven't been aware of submission of using Python. But who knows in 5 years, probably there could be some pilot submission starting with. And if there's some user needs or interest of using Python for end-to-end, I think it's more motivated by the business need and the organization need. Like what I saw is more like from the medical device. Nowadays, more and more software as medical device submission is happening, and many times machine learning algorithm is built in Python. That's one of the motivation we saw why Python can be a potential options to run the end-to-end submission if needed.
All right, I think there's another question. Can you comment on the lack of Python package review, testing, and curation versus R when it comes down to package repositories, for example, PyP versus Cran? How do you think this might affect the adoption of Python for clinical submissions?
Yeah, given the related submission now, would you want to take it?
Sure, yeah, great. And I'll just bridge into the next section part of our final part on submissions. Yeah, I think this is actually a question, and I do believe a lot of the packages are time tested. Obviously, as I mentioned, you need to be the product manager, right? And know the details about the entire dependency map well for your project and which dependencies are actually reliable and you need to choose them. And also, following the R model, I think there has been some very good community efforts being built around validating R packages or the R validation hub. And the white paper Yilong also contributed to, right? So you can actually do something very similar, I believe. Some companies have already started similar efforts on also qualifying Python packages, at least started with a kind of standard common methodology on how to do that, what we expect to see for effectively using these packages in a clinical context, right? So with that, I think I hope that kind of answers the question. Obviously, there's kind of it's more like distributed effort than Chrome does centrally for curating the packages. But I believe with sufficient community efforts, this can be resolved. Yeah, so with that, I think I can maybe share my screen just in case it's useful. desktop 2. There we go. Okay, all right. So next part is the submission, right? Let me just close this project, a file, close folder, to give us the default context instead of a project context. Let's see, can we open a terminal? Okay, all right. So apparently, this is very very similar mindset as Yilong mentioned from a few years ago. Why we actually started the R submission, how we kind of unblocked ourselves in actually making things viable, right, for the ultimate submission effort. And surprisingly, that's kind of come from very specific requirements from the technical study data technical performance guide from the regulatory agency, saying that you should actually submit your software programs in plain text formats instead of having binaries like ext files submitted. That's absolutely not acceptable, right? For very good reasons, I can see that. And although that could potentially create some verification problems for how we organize our projects, because as you can see, every single project is kind of a Git repo, and when it's cloned, it becomes a directory, and the directory might have different types of files that's not necessarily txt files, or there might be some binary files like proquet and everything else, RDS, right? So that's where we came up with this idea of actually converting or zipping this file, this directory or Python analysis pack or R analysis package into a plain text file, right? Everything in it will be encoded as a plain text format in a standard way. And on the reverse side, you can actually unpack this text file into the and restore the original directory structure, right? So and we will make this tool as an open source tool, so everybody can use it to pack things up, dry run it on the sponsor side and also on the reviewer side, right? So I think this idea has also got some updates from the very useful positive contributions from the R consortium R submissions working group for in the past few years. Apparently, there has been a recent update in August 13, 2025, in the FDA guidance, and saying that the eCTD module 5 can actually include .zip files for delivering R packages, and maybe also HTML files for demonstrating some results, right? So, however, there hasn't been any mentioning of other languages, but that was particularly for R, the update. You can actually check out this guidance document in PDF format and see for yourself. Python, another language, unfortunately, was not actually explicitly mentioned, right? So maybe we kind of need a similar solution. And actually, when we started this, this update hasn't been made to the guidance. So we actually were thinking maybe we can follow the very similar idea of doing this when we did this for R 4 years ago. But now, with better tooling and experience we gained in the past few years, maybe we can actually create a tool for that works for every single possible programming language, right? Not only limited to R packages. I think that's one of the biggest change we have made in Patchlight for Python. So yeah, you can actually essentially install Patchlight for Python very easily using UV add Patchlight. But here, I'll just demonstrate how do you do this very quickly using the two kind of submission package, analysis package repo, and the eCTD package repo as an example, right? So I just copy the git clone command mindlessly, and also this one, copy and paste to have these have these two demo projects available in my home directory. I can actually see what's available in each of them, right? So in the submission REPL, we have this, let me just get this larger so you can see it clearly. So in the submission package, as Yilong mentioned, this is a standard valid Python package, right? But also has all the quartal analysis notebooks or documents included. So you can render this effectively as a Python, as a quartal website. And then in the eCTD demo package, I think we have module 1 and module 5 included, right? So yeah, sorry, that was my bad. Demo by eCTD, right? And tree dot, right? So that's module 1 and module 5. In module 1, it's mostly some documentation on what we did, like including the cover letter. But module 5 is what we want to focus on today, right? Especially the analysis directory. And here under Atom, there are some data sets available, and also there are some programs available, right? And our goal is to make sure that everything you have written and tested properly locally for your analysis project to be able to rerun and generate all the analysis outputs from all the input data files, right? And the programs will be actually packed into the Python packages file, .txt, and each individual TLF generating quartal documents will be extracting the Python code blocks from them and actually removing all the unnecessary stuff such as comments and then putting them into TXT files, which are also essentially .python kind of scripts. And we will just be doing that right now, and following this chapter in the book. So after cloning the two repositories and switching back to the home directory, we'll be able to run things up, right? As I mentioned, you don't actually have to install PackagLite, although it's available as a Python package on PyPy. It offers a CLI interface. You can use this very easily in automations through the shell without actually having to code up things in Python, although it has a Python API. So like I mentioned, we can use UVX to run PackagLite directly. As you can see, there's some kind of lightweight installation happening, right? Although this has also been just run in the memory. And you can see some of the input and output commands. There are only 3 commands currently, PackagLite use, PackagLite pack, and PackagLite unpack, right? Just exactly implementing the ideas I mentioned before. By supporting a .PackagLite ignore file format or standard, we can actually ignore certain files we don't want to include in your original like source Python package, right? Into the end result. So it also follows the exact standard used in .git ignore. So these things are very easy to write, as I can show you a little bit later. So you can actually do that following this structure. First of all, let's create a .PackagLite ignore file for this source Python package. I'll just copy paste this. UX PackagLite use demo py esub, right? And you see that the PackagLite ignore file has been created. If we go there, demo py esub dot PackagLite ignore, you'll be able to see the content bit, right? Essentially, the very common patterns from the default template offered by PackagLite for Python. There has been some Python package, virtual environment files. Obviously, you don't want to include all those. And also for the R project or R packages, we want to ignore these things. And for Quartal, we also want to ignore all these hidden files, right? And for the operating system and Git directory themselves, we want to generally ignore all these files, right? So that's the default template you can use, which myself have been testing, and I think it covers a lot of the very common patterns we encounter. So we can avoid including a lot of these useless files from your source directory during the packing phase. And then very easy, one command to pack everything into the txt file that we want, right? Just run package pack through UVX with the input as your first argument, and then having dash output directory or output file, or -o, right, as an abbreviation, with the specific path you want this to exist. And we want this file to be packed into the eCTD package directory with this path. So you can just run this. You can see everything is super fast. I think after some benchmarking, I think for very large projects, it can write at 70 megabytes speed. Although if you write it in Rust, I wonder how things will be improved further. But here you can see every single file in your original directory, Python package directory, has been wrapped up into the txt file specified, right? With the this terminal output, giving you the hints. Yeah, so you can then maybe inspect the packed file a little bit. Here I would just use the head -n command, inspecting the top 20 lines of code in the txt file. As you can see, there's a header saying generated by package for Python, do not edit by hand, very similar to the R convention. And you can use package unpack to restore the packages. And you actually include very specific instructions in your analysis reviewer guidance document, ADRG, right? And we will cover that a little bit later. You can see an example. And then with all the actual content of the files included in your original package listed in the txt file here. And then after that, we can actually, as you know, package for R can pack multiple R packages together into one package, because you can also have multiple proprietary R packages depending on each other, or having a dependency tree relationship, right? That you want to submit. So you should actually check order them properly and install the lower level dependencies first and pack them first, then actually pack the higher level dependency later, right? So you can also do that using package for Python for packing multiple Python source packages into one txt file. Yeah, so I think that's so much about packing. Obviously, people are interested in converting the R analysis, like the vignettes in R Markdown formats into TXT files for their submission. So here we have a very easy way for you to do that for the Python Quartal documents very easily, and that is by leveraging some of the developer tools we have mentioned, including Quartal and also Jupyter Notebook. There's something called NB Convert, right? If you know what I mean. And then you can actually do some formatting using rough and stripping the comments using AWK. So everything is can be done through the glorious command line automation, right? Which I remember there's a very interesting book called Data Science in the Command Line, right? Where you can actually automate things through command line. And I think that's a very, very big part in Python development. So we can actually copy and paste this maybe directly into the terminal, although I wouldn't recommend that for security reasons. You should always check what you paste into a terminal. Okay, but here, since I wrote this, I think this is absolutely secure. So just paste this into the directory, and you'll be able to see that everything is working, and we'll be installing all the dependencies, triggering them in the respective directories, and actually have the I think have the things running in here, I believe. Yeah. And then we can actually check what's happening. You can actually move this into a shell script and run it yourself and reuse it later. Then it'll probably, yeah, it's working, right? Converting each of the Quartal documents into a certain format, and using NB convert to extract all the specific Python code blocks from the documents, and eventually have a standard formatter such as rough format to format the extracted code. Yeah, so well, that's working. Let's go to the next section. You can also automate this further by adding reviewer instructions individually, but we won't do that here for the sake of time. And then you can also verify if they are compliant with the ASIC requirements, right? ASIC only requirements. And this is kind of a bonus here, point here. There hasn't been any specific facilities built into the packages such as package for Python or RTF Lite yet, although we do have a existing verification script, kind of ad hoc, built in the developer scripts directory here in the RTF Lite source code. So just in case you are interested in getting this formalized into a standard a reusable function in RTF Lite or Patch Lite, please consider contributing to these packages. Oh, by the way, they're all licensed under the MIT license, so you'll be able to use them freely. And then you can maybe check things out. Oh yeah, they have been already created. Let's go to the eCTD directory. Let's see, M5, right? Module 5. So that's going to be a lot of tabbing programs, right? Okay, all right, there we are. See, all these specific analysis scripts have been packed into the TXT format. Let's maybe inspect one of them very quickly. Oh, I see we are on time. Sorry about that. Yeah, so this is one of the packed pure Python script, right? Yeah, and then you can see how you can, we offer some starting points for templating ADRG and ARM, right? For telling the reviewers which things are which, using which data sets and which languages they are using to create analysis. And then finally, you can have one single slide for dry run testing, right? Where you can just run UVX, package unpack programs, py0 packages.txt, and output the directory to a specific location and run all the dry run testing you want to run, right? And you can see all the details in this last chapter, dry run chapter, which is modified a little bit from the previous R4CSR book. Yeah, so I think that's all the content we have. So to summarize, I think Yilong might have something else to talk about. But I myself will say something like, know what's out there, try everything, and start building. Right? I wonder what Yilong might want to say as a conclusion here.
You really see that very well. Like this is like one of the project motivate me to learn Python. So I'm like learning and building at the same time. So this is like the first version for us to build the workshop, also self-motivated to see how we can contribute to the community. So if you have any suggestion or recommendations, please help us at issue PRs to our project. Much appreciate. And also super appreciate for the Pause's efforts to help on the Python side. So now you can see many of the tools and the package we are familiar in R that's actually available in Python, like the grid tables, React tables. Those are super powerful tools to get the ecosystem like end-to-end, and also not alone the plot9, that's a ggplot2 version of the Python package, right? So that actually lower a lot of the bar for us to use Python nowadays as like a statistician or data scientist.
Excellent. Thank you so much.
Okay, I just want to say a huge thank you to Yilong and Nan for an amazing workshop. You've shown exactly what the future might hold. It's a really exciting place to be. I'm a big fan of Python. Would love to see the industry adopt multiple ways of working and then utilize the best way forward. So huge thank you. Apologies, my camera's not working, so I'm applauding, but you can't see me. And just for everyone on the call, reminder, if you want the digital badge, fill in the form, it should be in the chat. And also there's a workshop, another workshop just starting on Bayesian survival, multi-state models with R and Stan. And a little bit later, there's a teal workshop as well, and that will close out R in Pharma this year. And so just to finish up, once again, huge thank you to Yilong and Nan for an amazing workshop. Thank you so much.
Yeah, thank you, Harvey, for hosting
the
field as well. Yeah, and thank you everyone for attending.
Thank you so much. Okay, I'm going to close the bridge now. Thank you.